Hello everyone, my name is Mohammad Hassan Tausif and I am making this YouTube video to talk about my physics, nanoscience and nanotechnology project. I have written a term paper on the fabrication of atomic force microscope tip using lithography. So let's have a look. In this paper, we have discussed two different fabrication methods of atomic force microscope tip integrated in a cantilever. The first one is a four-phase pyramidal metallic tip integrated in a silicon cantilever using E-beam lithography. And the second one is a three-phased high aspect ratio silicon nitride tip integrated in a silicon nitride cantilever. The reason for discussing two fabrication methods is that different probes have different applications in atomic force microscope. So let's have a look at the fabrication method of a four-phase pyramidal metallic tip integrated in a silicon cantilever. This one is a relatively old method for making conductive tips, and the process is as follows. As you can see in step 1, we are making pits in the resist using E-beam lithography. What is E-beam lithography? E-beam lithography uses tightly focused electron beam to scan across the surface on an electron-sensitive resist film such as PMMA. The pattern size is usually in nanometers, and E-beam lithography is a slow process and requires developing steps. In step 2, etching is used to transfer pattern onto the etch mask. Etching is a process that is used to remove excessive material from the substrate and is a top-down fabrication method. In step 3, anisotropical etching of pyramidal pits is done in the substrate using potassium hydroxide. Etching is anisotropic when etch rates vary at different crystal planes, leaving behind anisotropic structures such as the pyramidal pits. Step 4 is depositing layer of metal using electroplating and sputtering. And final step 5 is releasing of metal tip by silicon etching, which is isotropic etching. The tip is then integrated with the cantilever as explained in the term paper. The purpose for making this tip is to use for electrical measurements using atomic force microscope. Let's talk about the fabrication of second type of tip, that is three-phased high aspect ratio silicon nitride tip integrated in a silicon nitride cantilever. In this process, the tip and the cantilever are fabricated simultaneously in the same process. Initially, a circular hole is opened in the silicon oxide layer of substrate. Then, deep reactive ion etching is used to open a cone pit in the substrate. A TEOS layer is deposited using low pressure chemical vapor deposition. Then a silicon nitride layer is deposited for cantilever tip fabrication. Another TEOS layer deposited for anodic bonding with glass. TEOS layer is patterned to define cantilever, and finally TEOS layer and silicon wafer are etched. This is an SEM image of a high aspect ratio tip and cantilever fabricated using the method just explained. This method produces an ultra thin and sharp tip that helps in increasing resolution of the image taken. The three faces of the tip also helps in scanning deep valleys on a nanoscale topography of the surface. And silicon nitride is used because of its strong material properties to avoid wear on the AFM tip.